Okay, sorry. So I am saying that in a right angle triangle, the hypotenuse is always the longest side because it's opposite the biggest angle, the 90-degree angle. Now that will actually happen in all triangles. The longest side is always opposite the biggest angle. And if we want to swap that around, the biggest angle has to be opposite the longest side. All right, so if we are looking at that here, is 12 the longest side that we have in this triangle? We have three sides. We actually know what that side is, all right? But even if we didn't know what that side was, we could still figure this out. We know that this is 10.5. That is 12. That is 16. Now, the fact that 16 is the longest side actually means that this angle has to be the biggest angle in that triangle. So if I now calculated ATB as, what was it? 48.57. And I then do my second calculation, my second solution, which was 131. Now, guys, if angle ATB is 131 degrees, that is definitely the biggest angle in that triangle, right? Can you have a 131 and then another angle that's bigger than this in a triangle? No. So if I am saying that the second solution is valid, then that means that the biggest angle is opposite 12, opposite the side that's actually not the longest side. Right, so because of that, that's actually like an extra check that we had to do in this case, and it hasn't come up before. Because of that, actually, the second solution is not valid. Right, so let's see what I wrote down there. And now this size here is also different or wrong because I used the wrong value. I said this angle is opposite 12 centimeters, which is not the longest side. The 16 centimeter side is the longest, therefore the biggest angle must be opposite AT, that side, the side that is 16 centimeters long. So therefore angle ABT, the one that I put a dot in, has to actually be bigger than angle ATB because ABT is opposite the longer side. ATB is opposite 12, so this one has to be smaller than that angle. All right, so therefore ATB can't actually be the second solution because then it will be bigger than ABT, which is a bit of a mission to actually remember to check that as well. So I'm assuming that most of you guys would have written the second solution as well, if you worked with sign rule or not. Okay, yeah. But please write that down, right? That's just something else to keep in mind. And I look back at the other examples that we did, we actually didn't have enough sides to make that conclusion. We didn't have the side that was opposite. Yeah, we didn't have this specific combination of information. Yeah.
I'm just going to text. If you wrote down the second solution, then say one that
Please write that down in black there on the side. So if you put in the second solution, just write underneath it invalid, and that is the explanation. Well, there you go. a happy accident. Yes.
Do you have to get the exact same answer? Like, can you get 48.59?
Did you work with the unrounded value from TD? Yeah. Yes, that's fine. Yeah, so if you work with unrounded values all the way through, then your answer will still be what's the word, accepted. Once you've gotten your answer for 2.1, you can work with that as a rounded value going forward. But if you want to work with the unrounded values, just to be safe, you will still get it through.
So as soon as something that answers your question.
Yes. Okay, I'm just going to fix my 2.3, but guys, does that make sense? The whole biggest angle has to be opposite longest side. All right, so if you have all three sides in a triangle like we have now for this one, then it's a good idea to just do that check as well. Just to make sure that if you have the second solution will always be the biggest one, meaning it will have to be opposite the longest side. All right, and if it's not, then it also can't be the second solution. Okay, let me just fix my answers here. I'm going to freeze this so that you can finish writing that down. It said centimeters in the like paragraph next to it. You must always read the paragraph. Always, always. Okay, then it actually is the same. Okay, guys, are we fine at 2.2 now? Okay, 2.3. And they ask you to find the length of that whole secant, ABC, this whole line there. Oh, that whole line there. So we had that 12 already. So basically we needed to calculate BC so that we could add it to 12. Then we have the whole length. Now I haven't been filling in everything that we had here, but BC, if we want to find, remember we always check for sine rule first. That's usually what I do. So BC opposite, the angle opposite BC, we don't have that angle. But guys, do we remember tan chord theorem? Right? They told us that CT is a tangent. At that point, tan chord theorem is saying the angle between a tangent and a chord, so BTC, that angle there, is equal to the angle subtended by the chord in the alternate segment, so on the other side of the chord. So if that angle is 41, then BTC is also going to be 41 degrees. Okay, so if you get that, you have the angle that's opposite BC. Now we have that side, 10.5. We need the opposite angle to that side. But guys, we found ATB, we have that 41, we have that 41. So I actually worked with angle, sum, and triangle for this big triangle to get to that angle C. And then I had enough information to use sine rule in that bottom triangle. So let's see what I got. There I wrote BTC is 41, tan chord theorem. Then I found that bottom angle C by just minusing all of the other angles from 180. So that is now angle sum and triangle BTC, the whole triangle. I worked in the whole triangle to get that bottom angle C. And then I used sine rule to get BC. But they were asking for ABC, which is a whole line. So I just did BC plus 12. We couldn't have used cos rule in this one because we only had the one side. We only had BT. So unless you calculated CT somehow, that was the only way in which you could have used cos rule, but that also might be possible. ABC is the long side on the end here. So they gave us 12, which was AB right from the start, and then BC is the extra bit added to it. So it was this. It's that. Okay, just quickly 2.4. I'll show you the answer now again. Calculate the area of triangle TBC. So this bottom one here. Now, guys, this clearly is not a right angle triangle, so we need to use area rule. We remember that area rule is half one side multiplied by another side multiplied by sine of the included angle. All right, now guys, we had 10,5. We worked that out. Oh, I must just fix that answer as well quickly. So we calculated that in the first question, and we just calculated BC in 3.3. So it would be best if we can find that angle there, angle TBC, because that is then the included angle. Then we can do half this times sine of that angle. Now, what I did was I did exterior angle of a triangle. Do we agree that this angle is the exterior angle of the top triangle? You could have done that. That's fine. It would have given you the same answer. This angle is the exterior angle of this top triangle, right? We have 41 and we calculated this in 2.2. Remember, the exterior angle is always the sum of the opposite interior angles. So if you added those two together, you would have gotten that one. Or you could have done angle, sum, and triangle because we know that that's 41 and we calculated C for the previous question. You would get the same answer. Okay, so that's what I did. I did exterior angle of a triangle, but you could have done angle, sum, and triangle. Let me just fix this quickly. What is the answer if it's just 10.5? Almost 6.5. 6.1, thank you. No, the only way in which you can deviate is if you work with unrounded values all the way through, like from the top down. So if you saved every single value as like A, B, C, whatever in the calculator. But if your final decimal is different, then it could be because you, I don't know, maybe your rounding there was wrong or something. Yeah, so then that's probably why. Yeah, if you stored all your values all the way through, then your answer will be different. Slightly. But it will always be fine to work with the unrounded one. So if you're uncertain, rather work with the unrounded ones just to be safe. Okay, guys, I did not get to doing the rest of the homework. Sorry, I got home very late and then I have to be a mom and then I fell asleep next to my baby and woke up at 2 a.m. So I did not have time to do the rest. I'm going to give you a worksheet now on parabolas. It's a little exploration thing where you must find points, you must plot them, you must make a conclusion. So while you guys are doing that, I will quickly do the rest of the work and we can look at it. So guys, we are starting functions, but we will still, I'll just go show you the answers on the rest. I mean, ventilation. No, it's starting to work and then I'll open it again in Okay, guys, start filling that in the Okay, ready, lemons, you are going to sketch functions G to K on the grid below. Now, what you're going to sorry, I'm also looking out. I just thought there was a table for each of them. I suggest making a table of values for each of them, right? Because you don't know how to draw these yet. So if you see what they put in on the graph on the picture here is x squared. That's the basic one. Okay, so they have drawn x squared for you. Let me just show you here. I'll help you with the first one and then you can just kind of copy that method. So they have given you the graph of y equals x squared so that you can compare all of these new ones to it. Now, guys, do you agree or do you remember that we actually haven't done like a bracket squared? You didn't do those last year. Last year, the only thing that you did was you had a different a value, so a different number in front of the x squared, and your graph shifted up or down. Okay, now this year we're doing brackets as well. But guys, doesn't this look a little bit familiar if we want to think back to trig graphs? Sorry, it's quite blurry there. Let's see. That's the best it's going to get. If you had a trig graph, let's say sine of x plus 30 degrees, what happened to that graph? Can anyone remember? It shifted 30 degrees to the left. Okay, do we remember that? So if it was an x plus 30 in the bracket, the whole graph shifted 30 degrees to the left. If it was x minus 30, the whole graph shifted 30 degrees to the right. So the shift was always opposite to the actual sign. Now, guys, spoiler alert, the same thing is going to happen here. All right. If you have an x plus 2 squared, your whole graph is going to shift 2 units to the left, because now it's a plus in the brackets. All right, so the whole thing is going to shift 2 to the left. If we have an x minus 1 squared, because there's a minus, your graph is going to shift to the right by 1 unit. Okay, and then that one has a shift and an upshift. So I want you guys to do that on your own. Now, guys, in order to draw this, they've given you x values here. Let's say we're going to choose 5 x values. All right, can we choose the same 5 x values for all of them? You can do it on the calculator and then just plot your points. So let's choose x equals -2, x equals -1, x equals 0, x equals 1, and x equals 2. Sub those 5 x values into the equations. I'm just saying let's all use those ones. You can pick other ones if you want, but just so that we are all kind of doing the same thing. All right? Are we listening? So you're going to take your calculator, or you can do it in your head if you feel like you want to. You're going to sub in x equals -2 into this equation. All right? We might have to, sorry, I'm just thinking. Let's add some, yeah, because that's going to give you 0. Hey, let's also do -3 and +3. Sorry, because sorry. Let's do those ones. Okay, but you're just going to use the calculator, guys. If you're subbing in x equals -2 there, what's -2 plus 2? 0. What's 0 squared? So -2 gives you a y value of 0. So you're going to go to your graph. -2 gives you a y value of 0. Where's that point? On the x-axis. Hey, the point -2, 0 is on the x-axis. So that is a point that you're going to plot. Then you're going to do the same with all of these x values. You're going to plot all of those points, right? So the value that you get on the calculator when you're subbing in these x values, those are all your y values. You're going to plot them, and then those points you're going to use to draw the graph. Guys, if the points that you're getting is not giving you a clear enough idea of how the graph looks, sub in more x values. All right? You can always sub in more, and that will give you a clearer idea of how the graph looks. But start with these ones. Okay, then once you've drawn all 3 of these graphs, they're asking you some questions. Comment on how the coordinates of the turning point in each function relate to the equation of the function. Guys, what is the turning point of this graph that they've given us here? 0, 0. Right, so that is the turning point of a parabola, guys, literally the point where it turns. Okay, so you must look at the coordinates of each of those turning points and comment on them in relation to the actual equation. Then they're saying rewrite each of the functions in the form y equals ax squared plus bx plus c. Guys, are there any brackets in this form? No, so if I have brackets, what must I do to get rid of them? Square, I suggest writing them next to each other and foiling them out, all right? Simplifying so that you have it in that form, ax squared plus bx plus c. And then you're going to comment on these things as well. All right, so you're going to use the graphs that you draw in order to comment on these things. All right, and then I'm not sure how long that's going to take you guys, but then we can discuss it. And then you are going to sketch some of them for homework over the weekend, all right? But yeah, maybe just 1 or 2, not many. Okay, so guys, that's what you are doing for now. Let's get going, please. I want you to finish this before the end of the lesson so that we can talk about it. Take your calculator, take the equation of each graph, sub in those x values. So it's x plus 2 squared, so -2 plus 2 squared.
Please.
I'll give you a y value of 0. So you plot the point, -2, 0.
You plug every single thing
That you're going to calculate. Yes, so you're going to sub in all those values, and that will give you 7 points.
and it's all on that graph.
Yeah, so you're just drawing 3 different ones. So first you plot the 7 points that you get for this first equation, then you connect them. Then you're done with that one. You draw it like a parabola. Oh,
Yes,
no,
no,
yeah. And then Ria, when you're done with this one, then you go over to the next one. You start with the same values, plot all the points, connect them. So you're gonna have three different parabolas that you're gonna draw here.
So the values of x, is that going to change the way it moves this way?
So we're using the same x values, but every time you're gonna get different y values. So there's three different graphs. So then once you have all three of them, you can compare it. And you can actually see what happens when your equations look like that. Okay, but you first have to have the points in order to do that.
Three on one side, on the bottom.
Yeah, so well, not necessarily at the end. So that's why I'm saying, if you feel like you don't have enough points to actually draw it nicely, choose some other x values and sub those in. Okay.
Yeah. Wait, what is it? Yeah, mine. So just remind me how to edit the values.
So you type bracket, and then you type in the actual x value plus 2 close brackets squared. So it's not like a funny function, you literally just type in the equation, you just put it in the x value. Yeah, you're not going to use table points or anything, just type in the x value.
Yes.
Well, you don't have to step.
You don't have brackets.
Okay. Okay, so if it gives you values that are up, that are above. Yeah, it is like that because the parabola does have more like an exponential kind of curve. So in the beginning, it does, it won't jump at a constant rate between all of the So what you can do is you can just extend the one a bit further out, you can just kind of mirror the shape. Let's wait for the timetable to come out.